Okay.
If I were to say that like that, you'd get all off my butt and quit. What movie is it?
Okay, when you make your note card for the test, I would definitely label each section what it pertains to, and that's what the sentence I've been writing at the beginning. So what we're going to do today is find confidence intervals for population mean. So far, identical to 6-1. With a small sample. What do you think constitutes a small sample? Less than 30. So, several key things here. First, the population must be normally distributed. This takes us back to that central limit theorem. So if it's under 30, you have to know that it came from a normally distributed population. If it doesn't say anything about the population being normally distributed, you cannot do any statistics with it. Okay? So the population must be normally distributed. Here, the critical values based on the confidence level are t-values instead of z-values. So we've done z-scores. Remember we did the z-score for 90% confidence, the z-score for 95, we used the inf norm. That's the only difference is we're not going to use z's, we're going to be using t's. So the critical values based on the confidence level are t-values, not z's. Just because it's a small sample. So the first thing we need to do is figure out our t-values. There is no function on the calculator that will kick back a t-value. We have to use a table. So the first example is going to be finding critical t-values. Finding t-values based on confidence level. You have to use a table. The table is in two places. The table...
Are we supposed to know already how to find...
Nope, I'm going to show you right now. The table is on page A20 in the back of your book. And it's inside the front cover. If you go back past one page past that two-page, the z-score table that we're using, you'll see the t-table. So, take a look. This is the table we used before, that z-table. And if you flip one page in, you'll see what's called a t-distribution at the top. So it's not going to be, for like if it says 90% or 95, it's not always going to be the same number, like it was with the z's. So, oh, I forgot one thing here, sorry. There's a 3. Do you have room for a 3?
No. Seriously.
Oh. Because I forgot it, I missed it. It's one thing. It is. Degrees of freedom. known as DF, will equal your sample size minus 1. I could put it in example 1 too if you need to. DF stands for degrees of freedom, because you're going to see that in the table. So let's say, for example 1, we were going to do a 90% confidence interval.
Are we doing like A, B, C?
Nope. And our sample size is 25. So that's under the 30, so it's a small sample from a normally distributed population. What's going to be the t-value that we use in our formula? Well, let's look at the table. So, how many degrees of freedom does this problem have? Because if you look at the, yeah, you've got a DF for degrees of freedom, and I just told you that it's 1 less than the sample size. So we would have 24 degrees of freedom. So I'm on this row. And then if you look at the top, you've got level of confidence, 1 tail, 2 tail. What should we be focused on?
What is 1 tail and 2 tail?
That's in the next chapter. So 1 tail and 2 tail means nothing to you in chapter 6. So all we care about is level of confidence. What level of confidence did I give you? 90. So we can only do these ones, the 50, the 80, the 90, the 95, the 98, the 99. So the only ones that they can give us. So I gave you a 90. 1.711. So the t-value we're going to use in our formula is 1.711. So our by hand 3 steps for small samples. So small sample. The steps we're going to follow. For the population mean, by hand. This is like a new thing. No, we're done with that example. So your first step, just like before, is to identify your mean and standard deviation. So if they don't give them to you directly, they give you a list of numbers, you got to run your 1-bar stats. But most of the problems, they just tell you what these 2 things are.
Wait, is it standard deviation?
This is finding a confidence interval for the population mean.
Oh.
So then the second step is to calculate big E, your max error. And the formula is very, very similar to the one in section 6.1 with big samples. Do you remember what the formula started with? It was z-score. We don't have z-scores. What do we have? T. So it's going to be the t-value for the confidence level, because it'll change with the confidence level. Multiply that by the standard deviation over the square root of the sample size. It's the only difference. And then your third step,
Is this the third and final?
third and final.
Do you remember all of them?
Yep, I remembered all of them. So to get the interval for the population mean, what do? Take sample mean, then add and subtract big E, and you will have your interval. So let's try one.
So this is basically the same thing as yesterday. just
Basically the same thing as yesterday, except for this one change. So what's going to be on the test? When are you going to know to do this one? Versus the one we did the other day with Z's. The sample size. You're going to be focused on the sample size. Is it a large sample or is it a small sample? So when they're all mixed together, you better key in on sample size. All right, let's see.
N is 30, that's a large sample.
That's a large sample. So you go back to the Z section. There is one little catch here later on, but I don't want to make you nervous yet. Let's get the example going here. Let's see. Okay, we're going to select.
So did we get an answer for number 1 then?
Yeah, we did. 1.711.
Well, we got that right off the start by looking at the chart.
That's all I asked you to do on step 1 was find the t-value. I put values, but I wanted value. Yep, that was it. Okay, so we're going to randomly select 16 restaurants. And we are going to measure the temperature of the coffee that's delivered to the table. Measure the coffee temp. Okay, we find that the average temp was 162 degrees Fahrenheit. Standard deviation.
I feel like that's really tough.
10 degrees. I don't think so. Find.
You definitely would.
What you put in, what temperature is that hot?
It's like the temperature of like Subway soup. So think of it as being that hot, but it has to cool down before you eat or drink it anyway, so I mean, makes sense. Yeah, basically.
I love lava.
Well, Schwartz, you can't just leave us hanging like that. You
Oh.
gotta do something.
Okay, find the 95% confidence interval for the population mean. We're going to assume temps are normally distributed. Okay.
Okay, I always get confused on when you say confidence interval or confidence level.
There's both. Confidence interval, the interval where I put the parentheses from here to here, that's my answer. Confidence level is this 95%. So both terms are in play.
Okay.
Okay, now, so if this is a test, first thing I focus on is my sample size. That tells me small sample. If I've got a small sample, in order to move on, what else must I check for? First thing, the population must be normally distributed. Do they tell me that? Right here, assume temps are normally distributed. If that sentence wasn't there, if I had stopped right there, with just that given information, you would not be able to do the problem. Sample size is not big enough to do any statistic. So I am emphasizing it. There probably will be one, and if you go through and do the whole thing, -5 for you. So, there. Small sample, I need to know that it's normally distributed. Now I can continue on. Happy, happy. So, first step. Identify our important information that we're going to use. I need the sample mean. What is it? 162 degrees. I would like to know my standard deviation. 10 degrees. Okay. Second step is to find big E. Oh, I could identify N. What's my N? 16. That's just a little helpful to plug into the formula. Okay, if I look at the formula, what's the first thing I need to know? My T for my given confidence level. So, and my sample size. So, go to your T table. See if you remember how to read the T. It's going to be different for every single problem. So do we go to 16? Because that column is labeled DF. So what should we be going to? 15. It doesn't say N up there, it says DF. So we're going down to 15, and then reading over to 95% confident,
2.131.
2.131. Everybody agree with that? Because degrees of freedom are identified as, that was that third thing I stuck in there, degrees of freedom is always sample size minus 1. So 1 smaller than your sample size. Okay, and now we finish it up with multiplying by the S, which is 10, divide by the square root of the sample size, 16. So the max error, the most that I am away from the population mean is how many degrees? Sounds reasonable. 5.32, are we in agreement?
328.
328. Are we, must be in agreement now. So now our third step is to write the answer. I would expect the average temperature for all restaurant coffee to fall in between these two numbers that we're going to write down. That average for all restaurants, the temperature is going to be 162 plus and minus 5.328. What do you get when you subtract? 150.
6.67.
And then when I add, I can add pretty good. 167.328. Okay, now we've got the program.
What's the next thing you want?
Nope.
Wait, what's the answer to the last one?
167.328. So, small sample. Mean by program. So this your calculator must calculate t-scores because it uses it in the program, but there's not a button for us to access the t's. I'm assuming that's something that will come eventually, or maybe the new ones have it now. The old ones do not. I wonder if they've got an inv-t anywhere. Maybe you can get your maybe. Take a look at those distributions, that column. See if you've got something that has an inv with a t on it.
Yeah.
You do?
Yeah.
Wonder what does it? Can you figure out what you have to put into it?
Area and the
Oh, just like we look up in the table. Try it and see if it works with this one. Put in, only the newer ones are going to have it, because I know the old ones do not.
What is the T?
So the area would be 0.95, 95% confident. The DF would be 15, just like we look up on the table. Does it give you 2.131?
1.753.
that's what I got too.
Oh, that doesn't work. It must be the area thing that's wrong. I wonder if it's the area to the left. Try the area being 0.025. And then 15.
Negative 2.131.
Oh, there it is. Except it's the positive of it. So the way that's working is it's doing the center 95. So it's really not easier than the table. You've got to figure out what's in the tail. That's 0.025. And we want the positive one, but when we put in the 0.025, it just gave us the negative. So you can use that or the table. Doesn't matter to me. I knew that would come around eventually. The older calculators don't have that option.
I have no idea what you just did.
Oh, they did it. I can't even show you. I don't have a calculator that does it.
Was it shorter or
I don't think it was any, because you got to do the calculating of what's in the tail. Or the table, you just look up this and 15. I think the table's easier, less room for error. But anyway, the program is called Well, first of all, again, you still have to identify X bar and S, and then the program is under stat, over to tests, so if the other one was called Z interval, what do you think the name is here?
T interval.
T interval would be the best option. Not t-test, t-interval. The testing is in the next chapter. No, do not touch the test buttons. So let's go with the same problem we just did.
Is that the long way then?
Is what the long way?
Example 2?
Yes.
It's by hand.
So example 3, we are going to redo number 2. Let's see what we see if you can figure out what goes in the program.
Was that up there part of what we,
This started a whole new thing right here, this page.
right after example 2?
Right. So we finished up the by hand example and then we moved into something new, the program. So let's see what's in this little program of ours. Over to tests, probably right below Z interval, T interval. We have the stats. The mean was 162. S was 10. Sample size was 16.
What does the other mean?
Confidence level,
So, 0.95.
0.95. And then calculate. And it should be the same answer we just did. Look at that. All doable, right? Okay, that's pretty easy. Okay, same answer. And if I ended right there, you'd be happier than heck.
Wait, why are we not?
What?
Why isn't that it? Why are we
Oh, why is that not it? Oh, I'm going to tell you right now. Because there is one time where if you have a small sample, you're still going to use a z-score and do the problem like it's a large sample. So it just adds another little twist for something for you to look for. So, this little flow chart I'm going to give you,
Does it take, what was the C level?
95%.
Does this go along with example 3?
Nope, this is something new.
Okay.
Okay, so this is to decide Z or T.
How big is it gonna be?
Z, not too big. You can wait till I'm done if you want even. Or T is the question. So, first question. Is your sample size greater than or equal to 30? If you answer yes, should you do a Z or a T? Z. If you answer no, you have to ask yourself, now you've got a small sample under 30. The very first thing you need to look for is the population normal? Just like we did with the coffee. There were 16 restaurants. I told you to look anywhere in there. Does it say it's normally distributed? If you answer no, then what? It doesn't, you can't do it. You can't do either one. Can't do either. So we don't even put here neither, can't do, quit. What kind of thing you want? Neither? Neither. Can't do it. Okay, if you answer yes, it tells me it's normally distributed. Then you have an option. which standard deviation is known? If it's the population standard deviation, or if it's the sample standard deviation. Or maybe you know both of them over here. So, if I've got a small sample from a normally distributed population and I happen to know the population standard deviation, you are going to do a Z.
Is that S plus?
It's and. If I don't know the population standard deviation and all I have is S with a small sample from a normally distributed population, that's where we're going to do a T. So I can tell you on the test, I've got like 5 questions where it's not calculate out the confidence interval, but just tell me, should you be doing a Z or a T? So this flow chart is going to be very crucial to answering those 5 questions easily. And even on today's homework, I'm going to give you a section where I don't want you to calculate it all out because you already have enough practice with it. Just tell me, should you be doing a Z, a T, or you can't do it. So there's really 3 options there. All right, that's all I've got for you.
Wait, so for using the Z, if it gives you both of them?
Or just this. That's why I don't know how to put it. If it's just this is known, or if you know both of them.
Okay.
So as long as this is here anywhere in the problem, it overrides this. Does that make sense?
Okay, say that again.
Excuse me, can the following students please report down to the gym at this time? Madison Bailey, Emmy Barron, Veronica Boshaw, Zoe Berg, Morgan Bowie, Lily Capalupo, Sophie Carlson, Spencer Kazan, Brooke Lombard, Caitlin Leisner, Lauren McFarland, Isabella Matthews, and Abby Runkle and Sam Saylor. If you could please report down to the gym at this time. Thank you.
Okay. So it all depends on the problem. Sometimes they won't tell you the S, they'll just give you the sigma. Sometimes if you have to run 1 bar stats, you'll know the S, but somewhere in the problem they'll tell you this. So it's not always going to fit one little thing, but anytime you know this, you follow this branch.
Okay.
So even if you know both of them, you still follow this branch. Okay, your homework then. And I'm going to change the directions from the book at the end. Let's go with, starting with 11 down. Let's see, where am I? Wrong book. Stats. 6-2, page 271. We are going to start with this. Let's go 12 through 20 even. That doesn't seem like too many. So let's cut those in half. Let's go with, how many is that? 1, 2, 3, 4, 5. Let's go the first 3 by hand. So that's 12, 14, and 16 by hand. 18 and 20 with the program. And then the 21 to 26, all I want you to do is use this flow chart to tell me whether you're going to do a Z or a T. So 21 to 26, you're only answering Z, T, or can't do it. So just Z, T, or can't do. The book is asking you to do the whole interval business, figure out which one it is and do it, but I think you've already had enough practice with it. So are my directions clear as mud? Okay.